Chapter 5, we're going to start on area between two curves. So if we have, it's similar to just having two squares like this. So we have an outer square, the bigger one, and we have an inside square. So if we want to find the area in between, well, that means we just take the area of the bigger square and the area of the smaller square, and then just subtract them. And then we get the area in between. So 90 minus 54, we get 36 square inches. So that's similarly what we're going to do and find the area between two curves. We're going to be given two curves or two equations, and we're finding the area in between those two equations. So it might look something like this. So we have two functions, y equals x squared plus 1 and y equals x plus 3, and we want to find the area in between these two functions. Well, the first thing we have to do is we have to find, well, where do they actually intersect at? So we have to find our a and our b is where they intersect at. So for here, our a is -1 and our b is 2. So -1 to 2. And then what I want to do is, because the area, like we talked about last chapter, the area of y equals x plus 3 would be this area. And then the area underneath the curve of x squared plus 1 is this area. If we do from 1 to 2, I guess 1 to 2 would be more like this. It's this area here. So if we subtract them, that would be subtracting all of this. So it would be the area in between on these two functions. So what we want to do is we want to always take the top function, which you can see here on a graph. You can see which one's bigger. I'll show you how to do it when you just have equations. So you want to take the top one, x plus 3, and subtract that from the bottom one, x squared plus 1. And then you just got to make sure that you always distribute that negative into that second one. So we get -x squared plus x and then plus 2. So that's what we're going to take the integral of from -1 to 2, because that's where they intersect each other. So we take the antiderivative of this. So we have -1/3 x cubed plus 1/2 x squared plus 2x from -1 to 2. And you can always kind of remember that by taking the derivative of this, you get back to what our function was. Right. So now we want to plug in 2. So -1/3 times 2 cubed plus 1/2 times 2 squared plus 2 times 2. And then subtract, plugging in -1. So -1/3 times -1 cubed plus 1/2 times -1 squared plus 2 times -1. So that's the definite integral. So we can go ahead and simplify this. So we get -8/3, we get 4/2 plus 4. I'll take care of distributing the negative in a little bit. But -1 cubed still negative times 1/3 is a positive 1/3. This would be a positive 1/2, and this would be a -2. So now I can distribute the negative. That becomes negative. This becomes negative, and this becomes positive. Now I can simplify. I got -8/3 and a -1/3. That'd be a -9/3. 4/2 minus 1/2, that's 3/2. And then 4 plus 2 is 6. So then I can simplify this. 3/2 is just 1.5 plus 6, just 7.5. And then minus 9/3, it's just -3, so subtract 3 from this. And you get 4.5. Okay, so basically here are the steps. If you're not given a graph like we've seen, and we want to know what our a and b are, we just set our equations equal to each other. So like f of x equals g of x. And then we just solve for where these two equal each other, and that will help us find our a and our b. And then to figure out which one's on top, that's step 3 here. We plug in a number in between a and b, so pick a number in between a and b. So find some number in between a and b like c, and plug c back into both equations, and whichever number is bigger, that's the one on top. And then you go ahead and take the top minus the bottom. So you got to make sure to check and make sure the top curve does not change. And I'll show you how to figure out if the top curve changes and what you do on that problem. All right, so here's another example, just given two equations. And first we want to set them equal to each other. So x squared equals 2x minus x squared. So we go ahead and solve this, set one side equal to 0. So 2x squared minus 2x equals 0. Factor out an x. And so we get, or factor out a 2x would be easier. X minus 1. So that means 2x equals 0 and x minus 1 equals 0. So x equals 1 and x equals 0. So that's my a. So a equals 0 because a comes the first, which one comes first. B equals 1. So now I know my a and b. So once I know my a and b, now step 3 would be to pick a number in between here. So I want to pick 1/2. So I'm going to plug 1/2 into my equation. So here's my equation, y equals x squared. So I plug in 1/2 and I get 1/4. And then I plug in 1/2 into this one. And so here that's 1 minus 1/4. So that's 3/4. So which one is bigger, 1/4 or 3/4? 3/4 is bigger, so that means 2x minus x squared is on top. And then I'm going to be subtracting just plain x squared. And you could kind of graph this because we know x squared looks like this. We know a negative x squared is going to face down. So then we know we're looking for this area in between. So you can kind of look at the equation and see that this is going to be on top, 2x minus x squared. So now we can go ahead and take the integral of that. And our a was 0, and our b was, what was our b? 1. And so we're going to take the top function and minus the bottom function. So then we'll go ahead and simplify that. So 2x minus 2x squared. So we go ahead and add 1 to our exponents, divide by that same number. And we're taking the definite integral from 0 to 1. So this simplifies just x squared. So we can plug in 1. What's really nice about this one is we're plugging in 0 into our second one, so that makes it really nice. So we plug in our b. 1's really nice a lot of times because plugging in 1, you always just get 1 when you cube it or square it or raise it to a root or anything like that. So here we're going to get 0. Here we're going to get 1 minus 2/3. So we basically just get 1 minus 2/3, which is just 1/3. So there's our answer, the area in between this top function and this bottom function from 0 to 1 is 1/3. All right, so on this problem, we're asked to find the bounded area by these two curves. And then we have this boundary also, x equals 0, which would be right here. And then pi halves, x equals pi halves, which would be right here. So if I graph sine, I can see sine as always starts at 0, then goes up to 1. And then it comes back down after that, and then goes negative, right? Cosine starts out at 1 and goes down to 0 at pi halves. So there's some kind of intersection in between here. So we can plug these in, or we can just look and think, where does sine of x equal cosine of x? Well, that's at pi fourths, because sine of pi fourths and cosine of pi fourths. Right here at 45 degrees, we have root 2 over 2. They're both root 2 over 2. So at pi fourths is where they're both the same. And on this graph right here, we can see the blue one, which is cosine. So the blue is cosine. x, and the red is sine x. So we can see it switches here. So the cosine's on top from 0 to pi fourths, and then from pi fourths to pi halves, sine's on top. So what this is going to create is this is going to create two different integrals. So the first integral that I'm going to have is taking cosine of x and minusing sine of x. And then the second one is going to be sine of x minus cosine of x. And then it's just this area and this area. Well, I'm just going to add those two areas together now to give me the total area in between these boundaries. So for the first one, it's going to be from 0 to pi fourths, because that's where cosine is on top. And then the next one's going to be from pi fourths to pi halves, is where sine is on top. So we're going to take the integrals of these, and then we can add those together. So basically in your steps, when you take step 2 and you solve for x, if you get two x's, like just kind of like the first example, we got x equals 0 and x equals 1. So if you have two x's, then you have one integral. But if you get three x's, kind of like we said x equals 0 and x equals pi halves, and then we set our things equal to each other and we got x is equal to pi fourths. So there we have three x's. Whenever you have three x's, then you're going to come up with two integrals. So just like in our example, we have two integrals. So here we have our two integrals. So I'm going to take the integral of cosine x minus sine x. Well, that's just sine. Integral of cosine is sine. Integral of sine is negative cosine. So that becomes a positive cosine x. And then the same thing here is this negative cosine x, and this would be positive sine x, so that becomes a negative still. So this one I'm taking the integral from 0 to pi halves, and this one I'm taking the integral from, this pi fourths. And this one's from pi fourths to pi halves. And then I'll go ahead and add those integrals together. Alright, so I rearranged these in order here, rearranged so they're kind of better visual. So I got sine of pi fourths, that's root 2 over 2. I got cosine of pi fourths, that's root 2 over 2. So that's 2 root 2's over 2. And then I'm minusing sine of 0, that's just negative 1. Or that's just 1, distribute the negative. Cosine of 0, that's actually sine of 0 is 0. Cosine of 0 is 1, distribute the negative, so negative 1. So we just have minus 1. And we're adding the second part. So cosine of a half, that is 0, so minus 0. Bring down this plus sign here. And that is sine of pi halves is 1, so negative 1. So we just get negative 1 there. Pi fourths, that's root 2 over 2. And root 2 over 2, got a negative here, but we need to distribute that negative. So those both become positive. So we get 2 roots of 2 over 2. And so then we're adding those, because I distributed this negative to both of them. So then we have, simplify this to root 2 minus 1 plus another root 2. So we get 2 roots of 2, 2 root 2 minus 2. And there we go for that one. Alright, so when we look at using going horizontally, we just take the one to the right minus the one to the left. So when these are solved for in terms of y, so here when I set up the integral, it would be from where they're intersecting. I set up the same way. I set those equations equal to each other. Find my x's. I can plug in whatever x is between, say, negative 1 and 5 into both of these equations to figure out which one's bigger. Whichever one's bigger, that's the one to the right. And then I take the one to the right, which is y plus 1, and I subtract the one to the left, which is 1/2 y squared minus 3. And doing it with respect to y. So then I'll go take the integral same way as I did before, and then we can have whatever our area in between is. So that's kind of how you do these.